Hello everyone. Today is day. Sorry, I'm on the wrong page. Today is day. Which day it is? Today is day 24 of our 30 days 30 machine learning problems challenge. So the problem is about K means clustering to segment customers based on behavior. We have solved one problem using K means clustering. We understood how it works, we understood how it functions, we understood how it looks like. We saw, let's go and see which problem we use this K means algorithm. So on 14th day we use this algorithm to do what? To uh, to cluster grocery store customers, okay, based on their purchase history. And when we applied k-means algorithm, we saw it that how we make use of elbow method to find the optimal k. Now what is this optimal k? The number of clusters we should split our data into. So what we do, we perform an optimal k from 0 1 to 11, and then we find out, we build uh, we build this curve called as elbow method for optimal k. It builds the curve by doing what? It builds the curve by with respect to the sum of square distance from each point to its assigned cluster, okay, and plot it against the various k. Okay, when the k is this, okay, then plotting all the clusters against their nearest centroid, then this is how it is going to look like, the distance, and then sum of the square distance, that is inertia, and that is how it builds this curve. Now where we select that k value, that is called optimal k, where the elbow method, where we see an elbow in this curve. Now we do that because after that the distinction between each cluster is not much. So if we see here, if we split it further, it might split it into two, it might split it into a two, but the difference is between these points, the two split points of these two centroids will not be much. So we need to find the optimal k, and this elbow method is going to help us do that. So this is how the k means algorithm works, and we are not going to understand it again. Also, this was our first problem of unsupervised learning. um, and yes, and why it was unsupervised learning, I think you should go and go check the day 14 problem. There it would make more sense. So let's start solving this problem. Let me come back to this, and the flow is going to be same. I am going to use ChatGPT to help me code. The intent of doing so is that I want to just, since I'm on the, I'm just learning it, I do not want to uh, you know become overwhelmed with the topics. So I ask whatever new thing I see in the code about from ChatGPT, and I understand it. And hopefully the whole motto of doing this challenge is to learn by doing. So we are eventually learning, like, I did not have to go back and see what this particular algorithm is used for. So yes, let's get started. So I'll use the same context window. I'll say, hey, today is day 20. Which day it is? Day 24. And let me move this thing here. And here is the problem. Okay. So what it says that the K means clustering algorithm groups customers into cluster based on their feature similarity. This unsupervised learning method is useful when you don't have predefined labels, that is supervised, that is customer segments, but want to cover underlying structure in the data, right? That is called as supervised learning. So let's start first by creating a, before that let's figure out the data collection. You will need a data set with customer behaviors like purchase history, product usage, finance of frequency of purchases, and amount spent. We can get that from the, hang on, my cat is twitching. Yes, we can do what? We can go to the internet and search for this data from Kaggle. Now, what we are going to do, so if you have been following this challenge, you know that we get all our data from data set from Kaggle. We download it and then we experiment with it. Here we have customer ID, gender, age, annual income, spending. Okay, and how, what type of data? Purchase history, product usage, frequency, and amount spent, gender, age, annual income, and then spending score, which is score assigned by the mall based on customer behavior. And okay, I don't want to. Hmm. Let's see if this is data will be enough. Age, gender, and then so this is similar data. So I'll go and use this data only, and let's download. And how many customers does it have? My cat again. I'm really sorry. Yes. Yes, I have the data. Now let's do what? Use the PyCharm to move this data from the downloaded folder, and the name of the file was mall customers to our dataset folder. We should have the dataset here, and yes, we can see the dataset here. And let's close this and clear our terminal. And then let's do what? Move the up the terminal a little. Let's do what? Let's create a Python file, and it is going to be day24.py. Let's and add it to our Git repository and start. So I'll say the problem is, what is the name of the problem? Key means clustering on customers based on behavior, and the data set we are using is from this problem. Let's import. Okay, I'm starting pandas as pd, and step number one would be load the data. And here what I'm doing, I am loading the data as from pandas using read csv. Here specify the data set, and here the file is going to be mall underscore customers. And let's print the data info, which is from this data frame. We want to see what type of, how many columns it has, what is the data type for those columns, how many rows it has. And then we are going to see some rows, as in some data like five rows from the data. Let's run this, and this is how it looks. It has four columns. customer ID, gender, age, annual income, and spending score. And then it looks like this. Okay, so now I'm going to copy it. It has 200 entries. I'm going to copy it and do what? I say, hey, I have downloaded the data set, and here how it looks from panda data frame data. Okay, it is done. So let's start. So it says we have to do pre-processing. What do we have to do with pre-processing? Since we are applying k-means clusters, so what we have to do, let's go back to our day number 14 and we see the pattern that we used on that day. We pre-process the data, and first we what we did, we wanted to make sure we are handling the missing values. And then we did what? We applied scaling, because we wanted to have a standard scaling across all the features. And if you know, if you've been following previous videos, you see that yesterday also we have applied scaling technique. Just to give you a brief of why we do that because uh, we want all our features to be on the same scale. For example, once we have height and width, okay, and width, the range of values for width feature is from 100 10 to 1000, and the range for width sorry height is from 10 to 100. See, the width range is from 10 to 1000. Now when the model is being trained, the width, because of its high range, high scale, it can dominate. Now we don't want to make our model biased towards any feature. That is why we do scaling, so that all the features come across single scale, similar scale. Like after applying scaling, the mean comes around 0, standard variation comes around unit. So that is why we apply scaling. And if you are still clueless about what it is, we have explored on day 7, I guess, about this. And I recommend you guys to follow the full challenge, all the videos, or at least the post from this tech journal. So yes, that's why we apply scaling after handling the missing values. And then we find the optimal k, and then we using elbow curve, and then we simply train the model and then visualize it to see how it looks. So let's start. Now what we are going to do, here it says, assuming you have already loaded the data as data, dropping the customer id column as it is not useful for clustering. Okay, makes sense. What we are going to do, step number 2 is data pre-processing. What we are doing, drop customer id as it is not useful for clustering, right? For clustering, we it is not going to help with anything, right? It is not a feature. That is, yeah, that is not it is not a behavior, it is just an identity. So what we are going to do, data dot drop, sorry, this column name, and we want to drop the column, correct? Now what we are doing, we are going to do what? We don't have gender, we do have gender, right? See, we what we can do, we can encode gender if you'd like to. Yes. Now our gender, encode gender as you know why gender is in like male female. We want to convert it into 0 or 1 so that you know what, uh, becomes easier for our model to get trained, right? So we'll do what, gender male for 0, female for 1. So what we are going to do, data gender data dot map data gender map male will become 0 and female will become 1. Is that right? Yes, I'm doing it right. And then we will do what, we want to now select the features. I just want to handle the missing values. I want to print the missing values. So what do I, how will I do that? It is not mentioned in this code, but I want to do it for my satisfaction. So I'll do data drop, no, data is null, and I want to sum, print the sum of each feature. And I'll do what, I'll comment it, and I'll rerun it, and I'll see that it is not continuing. We don't have any missing value. So handle missing value, I'll comment it. Now what we want to do, we want to apply scaling. So first select features for cluster, and how many features we want, it says that we want age, annual income, spending score. Age, annual income, spending score, yes. So I'll just copy it, and the features are going to be data, and return in 2 dimensions what, this age, annual income, sorry, this is a separate string, and okay, I should be copying it as this, and then I'll copy this as well. I want gender also. Chat GPT is not doing anything there, but I do want gender because I've already converted it into I mean numbers. So yes, and we do not want the target here, right? So are the features list is this. Uh, Select features for cluster. Now we want to apply scaling. So what we are going to do, we are going to import first what, standard scaling. We are using standard scaling, and we have used this before as well. So if you are curious how it works, I have clearly explained it, I guess, in problem 7 or 8, as in day 7 or 8. So yes, you can go and check out that. So from sklearn dot I guess ensemble, no, pre-processing, import standard scalar, yes, sorted. Now we are going to create an object of our standard scalar. Then we are going to scale the data scalar dot fit transform x. Yes, we have scaled, and we the new variable is scaled, x scale. Now what we are going to do, data preprocessing we have done. This is going to be step number 3, create features for cluster, and then we will apply step number 4 is apply scaling. Yes, now we want to use elbow method to find the optimal number of clusters, as we have seen on day number 14 as well, and I've just explained you why. So step number 5 is apply elbow method to find the optimal k. Okay, uh, optimal number of clusters, which is k. So what we are going to do, I forgot actually. Yes, within clusters sum of no. What I'm going to do, I'm going to use the same code. If see if I that is going to work. So I am creating a sum of squared distances for of each k. Sum of squared distance of from each point, and this is an empty list. Then we are going to range from k in range 1 to 11. What we are going to do, we are going to use k means, where we are defining that it will have these many clusters, the random state, and this the auto. Why do we need this auto? We want it to train it automatically, as in we want it to s- split the training and data, the other data set, randomly. I'll still go and check it. I need to see why we are doing it. Why are we doing this? So the pap, this is different from the day number 14. So this initialization equals to k means plus plus parameter is the k in the k means algorithm is used to improve the initialization process of cluster centroids, which leads to a better results and faster convergence. Okay, so this is a way of doing what, clustering. We need to improve, we need to set the initialization process for our clustering process, k means algorithm. So it says in the standard k-means algorithm, the initial cluster centroid, the starting point of each cluster, for each cluster are chosen randomly, okay, from the data points. This random initialization can sometimes lead to poor cluster quality and slow convergence. Okay, if the initial centroids are chosen poorly, then they lead to poor cluster quality. With with k means plus plus, what it does, the k means plus plus initialization method is a smart way of choosing the initial centroids. Instead of choosing the random points, k means spread out the initial centroids as follow. It first randomly selects one centroid from the data points. Then for each remaining centroids, it selects the next centroid from the data points that are far from the already chosen centroids. Okay, so it is a way of choosing the centroids, initializing the centroids. First, it does what? By default, they get selected randomly. But with k means plus plus, what it does, it first selects randomly, and then do what? It selects next centroid from the data points which are far from the already chosen centroid. So it does not include the already chosen, and it also makes sure that it is selecting the next centroid which is far from the data points. So the probability of choosing a data point as a centroid is proportional to its distance from the nearest already chosen centroid. This ensures that the initial centroids are far apart, which usually leads to better clustering and faster connectivity. Okay, makes sense. So this is a way of selecting the centroids, which is different from randomly selecting. That comes under standard initialization problem. Here it selects randomly, and then the next centroid is selected on the basis of how far it is from the data points, and is not from the, and also from the already chosen centroids. Yes, so how far it is from the already chosen centroids, it selects the next centroid in this way. So yes, this is how it does. So we have understood it. So let's do what, let's import some libraries first. So what do we have to import? We have to import from sklearn.clusters import k-means. Okay, yes. So let's come here, we have come here, and we are going to do what, we are going to create an object of our k-means. Here we specify how many clusters we want k clusters. Okay, which is in the range of 1 to 11. Then how do I want to initialize? I want to initialize with k means plus plus, which randomly selects the centroid, and the next centroid is selected on the basis of how far it is from the already chosen centroids. So what we are going to do, we are okay. Then we want one more thing. We want to do one more thing, and what is that one thing? We want to specify random state. That is, whenever we are running this code, it generates the similar output. Then we do what, we train our model on this cluster using on the scaled features, and then we are going to store this, the inertia, the sum of squared distance, the inertia, we can call it as inertia in this. So it is going to be k means dot inertia. Okay, once done, we are going to build the elbow curve. Plot the elbow curve. Okay, so what we are going to do, we are going to use, first we need to import some libraries. So import matplot.py plot as plt, import, yes. And what we are going to do, we are going to create a figure of size 5 is to 7, and then we are going to plot the graph, and the range is from range 1 is to 11. So the x-axis is going to be k, which is from 1 to 11, and the y-axis is going to be inertia, and the marker is this, hang on, o, and the line style marker is o, and line style is going to be this. Let's mention the title is going to be elbow curve, and the x label is going to be of k value, and the y label is going to be inertia. or what we call sum of squared distance. Yeah, let's inertia, and then we will simply show it and find the optimal k. Okay, let's run it and we see an error. I think 2 or 4. I guess this is the 2 should be the answer, or either 4, either 2 or 4. So let's do what? Let's do this. And so yes, so we need to suppress the warning. So what we are going to do to suppress the warning, we need to do this, and init to auto, and we will change it to 7 is to 5, and run it again, and this is how it is coming. Okay, either 6 or either 4. I guess I'll go with 4. So I'll take this screenshot of how it looks, and yes, I'll take 4, and this is how it looks. I'll go ahead with 4. Okay, so optimal k is 4, and then we'll do what? Apply key means with the optimal number of clusters. Step number, which step it is? For us, with step number 6. Apply optimal k means on the optimal number of clusters. And here it says k is equals to 4. And we'll do what? Move this to here, and then we are going to create k means similarly how we have done inside this for loop. K means, here we specify the number of clusters as optimal k, then we say how we want to go ahead with this. I'll copy everything here, as we've already understood how what it means. And the predictions, why predictions? I'll say yk means. So it is yk means, and it is going to be k means dot fit predict on x scaled. And what we are going to do? We are going to do step number 7 is visualize. Visualize the clusters, as that is we want to see how the clusters look like this. Okay, so let's go back here and visualize using what? First we have to define the figure size, which is going to be 10 is to 7 is to 7. Okay, then we have to use Cbond library, which is Cbond as SNS, one space, and here we are going to use scatter plot. Here we specify how we want to as in huh, I'll say, can you please explain this? So we are using Seaborn's scatter plot function to plot a scatter plot, visualize the clusters created by the k-means algorithm. This function from Seaborn is used to create scatter plots. Scatter plots show data points, in this case customers, in a 2D space. Okay. Where each point represents a customer and its position reflects their features like annual income, spending score. This X scaled is the scaled version of the features matrix that we got from by applying this scaling technique through standard scaler. This shows that we are selecting the second column, and it shows that we are selecting the third column. Okay, which is annual income. Here second column is annual income. No, R is third column and fourth column, annual income and spending score. Therefore we are plotting uh, the annual income against the spending score. Okay, so here we do not want to do that, so what we are doing, so here it is going to be X scale. So it is going to be, which we have added gender also, so we have one first column, seconds, third column and fourth column, third and fourth. Third, as in, sorry, it is going to be 0, 1, 2 and 3. 2 and X scale, Y axis is going to be third, which is annual income on X axis, annual income on x-axis, and third 0, 1, 2, 3, third on y, spending score on y-axis. Okay, and then what it wants, this uh, this hue parameter is used to color the points based on the different categories. K means in the array that contains cluster labels. Okay, so it makes sure that we are coloring each cluster differently, and argument controls the color scheme. So we are using words which is widely used color map in the data. Okay, again for clusters. Okay, okay, sorry, as in which, so which cluster we want to plot, what we want to plot these clusters, and in what color. So we are going with color name is Viridis, Viridis, which is a widely used color map in data visualization for clusters. So here each cluster will be assigned a different form, color from its from palette, and S represents the number of so control the size of the markers, which is this dot. So here S represents what, the size of the marker. We are going with 100 as it shows in as this chat GPT is using. Okay. So now we are going to do what? We are going to define the title of this plot, and title is what? Customer segments K means cluster. Okay, and then we are going to, the X label is going to be annual income, and the Y label is going to be spending score, and we will simply show it. Let's go back to our code and do what, run it. This is our elbow. We went ahead with K4, do not see. We do not see the this thing. And why? Because we have an error. Why do we have the error? uh, hmm, how many columns we have? Zero, one, two, three, right? We have three columns. So we want to plot the graph like that. So it says that, okay, so we have this. I want to see how we have plotted before. I guess we have plotted similar as in like that only. Right? Is provided more position argument than it expects. Function expects x and y axis as keyword argument, not position arguments. Okay. Is that what we were doing here as well? No, we did not do here. Achha, here we use the scatter, not the scatter plot. We use the from matplot only. Here we are using from Seaborn. So we are using from Seaborn. So here it says x equals to. So it is a little different from that problem. Let's run it, and this is how it looks. Okay, we still have a lot of clustering, right? So I'll go and change it to, you know what, I'll change it to 5 and run it again. This is 5, 6. I guess I'll go with 6. Still better, no? So I'll go with 6. Still they're coming like together. No, no, no. I guess we are taking too many clusters. I'll go with 2 and let's run it. So here I'll go with 2. No, I went with 3. I'll go to. Here's the elbow, and we still have like this is they are too tightly coupled. Hmm. So here I'll go with 4 as we saw earlier. Uh, so here it is separating this, and this. Okay, so we do have some differentiation. I'll do what? I'll take this screenshot so that I can use it for my progress post. And yes, so this is it. Our code looks solid. We have correctly implemented it. Now we are going to do what? We will add it in our original data. And yes, I don't think that is needed, but yeah, let's add it if chat gpt says so, because we are in no position to use our extra. We are in a no position to, we are in a position to learn actually. Try to use negative words as clusters information for each row to original data. So data clusters, and it is going to be our yk means, and we are going to do what? Let's print it. Let's see everything again, and this is how it is looking like, which cluster it belongs. So yes, the data looks solid, the graph looks solid, and this also looks solid. So we can do what? We can commit it and then jump onto the, yeah, we can commit it and close the video. Uh, yes. So do what? Edit 24, commit it, add code for day 24, main branch, and it will open us the repository page. Here we should see the code for today's problem, and it looks solid. So yes, thank you very much. Now I'll go edit this video, upload it on YouTube, and after that upload the textual format of what we have done so far today, that you can find on this tech journal. Thank you very much, and see you tomorrow.